Space elevators. Many consider this option as a fallacy or something from science fiction. The truth is that this alternative is closer than you imagine. Arthur C. Clarke wrote, "The space elevator is an idea whose time has come." You may now terminate your imaginative trip into space in a space elevator because in just 25 years, 2049, there well may be a space elevator that transports people and materials as far as the apex anchor, 100,000 kilometers, and then send them on to the moon and beyond. Space elevators are no longer just a figment of an author's imagination. To give a good example of why a space elevator is better versus traditional rockets, we can say that the Apollo example shows that only 0.5% of the pad mass at Cape Canaveral was delivered to the surface of the moon, with the rest consumed or thrown away. Yes, reusability improves costs and reliability, but it does not improve efficiency of logistics delivery. To better illustrate what we are trying to explain, let's take the following example. Imagine the island of Manhattan, with all its population, its businesses, jobs, in short, everything that is done on this island day after day. Now just imagine that all the logistics, both of people, removing garbage from the island, logistics of goods and services, in general, everything that is done to maintain the pace of life on this island, is done through hundreds of ferries, since no bridge has been invented to date. It would be almost impossible to imagine, right now, what would happen if we built the first bridge, and not necessarily a big one. Imagine a bridge with only one lane going and another coming back. With this simple fact, the use of the ferry would be surpassed by far and forever. And this is because we are dealing with a fixed or permanent transport structure, which has many advantages over a ferry, such as that it does not pollute the environment. It allows the shipment of goods and services in both directions continuously and faster, in a safe, routine, efficient and economical way of all types of merchandise. It's basically the same comparison between any space rocket and a transport ferry, and a bridge with a space elevator. It's a permanent access structure to space. In a specialized factory, the tether with a length of 100,000 kilometers will be manufactured continuously. As the tether is rolled out, the coil will have a custom diameter, so that it occupies the entire cargo area of a SpaceX Starship rocket. The roll will be stacked on top of the first one without cutting it, roll after roll, until the 100,000 kilometers are stacked one on top of the other, continuously. Meanwhile, simultaneously with all of the above, a custom Starship rocket will be assembled by the SpaceX company. Once the complete and continuous roll is packed into the Starship rocket, it will then be mounted on Booster 9, to be launched into a geosynchronous orbit, GEO. And the Starship will continue its journey until it reaches a geosynchronous orbit, GEO, while Booster 9 successfully returns to Earth. Once the Starship rocket reaches GEO, it will be hovering at a point that is close to its alignment with its tether on Earth's surface. Then 2 modified Falcon 9 capsules will dock. We will call them stabilization satellites. They will move and align the Starship rocket so that its upper part will be facing right at the anchor on Earth, and its final part will be perfectly aligned where the apex anchor will be located. Once the top of the rocket is perfectly aligned with its anchor on Earth and the back of the rocket is in line with where the apex anchor will be, then the stabilization satellites, one will drag the Starship to its final destination at the apex anchor and the other will head towards its anchorage on Earth. The stabilization satellite will slowly descend until it touches the surface of the sea, near its anchor in the ocean. In this case, an oil-style platform located on the equatorial line in the Atlantic Ocean. And simultaneously, the Starship rocket must be located at its final point, perfectly aligned with its opposite, the anchor on Earth, in this case the 100,000th kilometer, to become the apex anchor. And this is how the complete system would look from the anchor on Earth to the anchor at kilometer 100,000. Climbers are the machines in charge of carrying and bringing the merchandise from the surface of the Earth to geo and/or the apex anchor and back. Important note: the astronaut is 2 meters tall and his purpose is to give an idea of the dimensions of the objects in this video. In this video we will assume that the tether has the following dimensions: a width of 1 meter, a length of 100,000 kilometers and the thickness of a sheet of paper. In this video we will assume as an example that the company, Tesla, is in charge of manufacturing the climbers that will be used in this video, and they will be composed as follows. Tesla electric motors will be custom-made and must be powerful, reliable and able to withstand the harsh environment of space. Special tires that can withstand friction in the space environment. Both the motors and the special tires are configured in such a way that they press the tether from both sides precisely, so that it can go up and down. They are covered by an extremely resistant and at the same time light chassis that helps press the tires against the tether. It is made of a material that refracts sunlight and has built-in anchors where the containers that carry the merchandise are attached. Energy receiver. The energy receiver is shaped like a satellite dish and serves to receive energy in the form of microwaves or laser light that is sent from Earth. Electric pantograph. The electric pantograph is incorporated into the satellite dish and its function is to share energy with other climbers in case of a failure. The dimensions of the containers are as follows: 2.6 meters high, 2.43 meters wide and 1.7 meters deep, and the climber can load 10 of them. As previously mentioned, this example of a space elevator will be located on a platform in the equatorial zone of the Atlantic Ocean. And the way in which the climbers will receive energy is by placing powerful satellite transmitters along the countries that are coastal with the Atlantic Ocean. And from them lasers or microwaves will be emitted to feed the climbers throughout their journey. Back to the apex anchor, the most important section of this whole permanent space access structure. Its first function could be to become a humble gas station. From here, spaceships could stock up on provisions and refuel as their last stop before embarking on interplanetary missions. Climbers could carry cargo and all necessary fuel to the apex anchor and keep the oxygen and methane tanks, and even the cargo area of the starship full by means of a custom inflatable capsule that has the shape of the entire cargo area. And in this way the ships could be recharged, since everything would be waiting at the apex anchor for the ships to arrive to be resupplied with everything necessary for them to carry out their missions at their destinations. A release point for interplanetary science missions with space systems of any size, assembled at the top of the gravity well, to any planet with daily windows. Interplanetary human missions, after development of full operational capability, with space systems of any size to any planet with daily windows. Inflatable habitats to house scientists, rescue personnel, astronauts and personnel heading on interplanetary missions that include solar panels to meet energy demands. Astronaut rescue staging area with storage of necessary rescue material such as oxygen, habitats, water, rocket fuel, power, and food. Only 14 hours from the Moon. Planetary Defense Asteroid Detection Sensors. With multiple 100,000 kilometers tethers on each side of the Earth, 206,000 kilometers baseline, for stereoscopic vision of incoming asteroids from the Sun or out of the asteroid belts. In addition, the storage of planetary defense spacecraft would enable rapid response to near-term threats within 24 hours. Flexibility of responses can be accomplished by storing, then rapid assembly of various defensive segments of planetary protection space systems, depending upon the threat. Interplanetary full-service logistics, storage and resupply capability with just-in-time delivery, cislunar full-service logistics. Storage and release for supply missions with just-in-time delivery.